Welcome to solving logarithmic equation. So the previous video is about solving exponential equations. So let's take a look at how we're gonna solve our logarithmic equations in this particular video. So techniques, different things, different properties that we can use to help us to solve these log equations. So this is new. The property of logarithmic equality. So what this is saying is if I have two terms, okay, and both terms involving with logarithm with the same base, okay, if that's the case, then what I can do is set what they are of equal to each other. Okay, so if I got two logarithms that have exactly the same base, then and they are equal to each other, so then I can actually set what they are of equal to each other. All right, I bring this one back, the changing of logarithmic bases. Okay, sometimes we might have to use this one to help us solving equations. Convert between exponential and logarithmic equations. We talked about this one before. So rather than solving it from the logarithm perspective, we can actually convert them into exponential. This technique is very unique because number one is two logarithms with the same base equal to each other. We can set what they are of equal to each other and solve for x. So if I again have two terms, only one term have logarithm, the other term don't, then I can actually convert my logarithm into exponential and solve it from the exponential perspective. All right. We talked about the property of logarithm before where we introduced the log of product, quotient, and power. So sometimes we can use those to help us solving our logarithmic equations. So let me start out with the easy ones, okay? Very, very easy. So there's other techniques involved. These are just the basic properties that we tend to use more often. But there are other techniques, okay? Just like this one on the right, the natural log of x equal to 5. To get rid of the natural log, this one only got two terms. To get rid of the natural log, I will simply take an e on both sides. See, that's one technique I didn't list up here. So now the natural log and e will cancel out. Only thing left is x. So x is equal to e to the fifth. So that will be my exact answer. So my approximation, e to the fifth, 4 decimal place will be 148.4132. Okay. 4132. Yep. All right, this one on the left. It's kind of weird because Mr. Chen, how do I get x by itself? Well, the variable term is on the right side. So to get x by itself, all I got to do is divide both sides by 3. Okay, since I only got two terms, so the only thing I can do here is divide both sides by the coefficient. So the log of 2021 is just some kind of irrational number. So we're just going to put this in the calculator. So my exact answer is log of 2021 over 3. So let's approximate. So log of 2021 is only one term up top. So just make sure you close the parenthesis before you say divided by 3. So we have 1.10. 1.19, excuse me, 1.1019. All right. Now these two right here is actually written in a little bit of, written kind of like an exponential, especially this one on the right. So interesting, making the base the same, I can make 16 into a base 4. So I can have, this is 4 times log with a base 2 of x equal to 4 squared. So when the base are the same and base are equal, then we can set the exponent equal to each other. So this is actually log base 2 of x equal to 2. So now what I'm looking at here is two terms, one term with a logarithm, one term don't. So I can actually solve for x by convert my logarithm into an exponential. Well, that's what I'm going to do. Move this 2 over to the other side. That becomes the base. Bump the 2 to the exponent. then my x will equal to 2 squared, which is exactly 4. All right. This one right here, I can do exactly the same thing. Move the 3 over. Okay, one term with the log, one term don't. I can convert them into exponential. So the left side would just be 27 to the 2x power equal to 3 squared. So I'm going to make my 27 into a base 3. So 27 into a base 3, that's the same as 3 to the third. But since I already have a 2x power on the outside of it, it will look something like this. 3 to the third to the 2x power. So by the power rule, that's going to be 3 to the 6x power equal to 3 squared. So once the base are the same and base are equal, I can set the exponent equal to each other. So my exact answer will be 1 over 3. Divide both sides by 6. All right, so both of these are very similar. Okay. I'm trying to make the base the same, so we can set the exponent equal to each other. All right, this one right here is just like up here. Two terms, one term with the log, the other term don't. So to get x, to solve for x, I'm going to move my base to the other side. All right, so I'm using what? I'm using convert between exponential equation and log equation to start this actually start this problem. So that gave me 3 to the 4th power, right? Bump the 4th up to an exponent. This is 2x minus 1. So real quick, 3 to the 4th power is 81. So what I'm looking at right now, this is actually a linear equation. So this is going to be 2x minus 1 equal to 81. Move the negative 1 over. That give me 2x equal to 82. X is equal to 41. Okay. So I'm just solving it just like a normal linear equation. All right, this problem, what would I do? Well, to get rid of the natural log, so I'm going to E on both sides. So it's very similar to this first one I show you, because the natural log and E kind of cancel each other out. So that leaves me with ax minus 7 equal to e to the 14 power. That's okay. It's just some kind of e to the 14 power, just some sort of irrational number. So move the negative 7 over. So that gave me ax equal to e to the 14 and then plus 7. Divide both sides by a, or divide every term by a. So my exact answer will be e to the 14 plus 7, both terms over 8. All right, let's put it in the calculator. I'm going to figure out the top first, okay? E to the 14, right? So close a parenthesis, because that 14 was on the exponent, then plus 7. This is my top, divided by 8. 4.3752. All right. That's it. All right. This one, again, 2 terms. Both term has a natural log. So this problem, I can actually use the property of a logarithm equality. Okay. Remember, natural log is just simply a log with a base e. So since my natural log, both terms have natural log and they are equal to each other, then I can set what they are of equal to each other. So that gave me x minus 5 equal to 2x. Move the x over, so that will be x equal to negative 5. But now think about this, okay? If I plug in negative 5 where the x is, that will actually be negative 10 here. Cannot take a natural log of a negative number. So I actually have no solution. Because if I plug in negative 5 into any one of the x, I cannot take a natural log of a negative. So this problem is no solution. All right, let's try one with more than 2 terms. So this one has 3 terms. So where do I begin? Well, the reason why we talk about these properties, the log of product, quotient, and power, is so that it can actually help us solving logarithm equation. So right now, my problem has 2 terms with a log on the left side. What I can do is make them into a single logarithm. Okay, so once I can get them into a single logarithm equal to something else on the other side, then I can either convert between, then I can either use, then I can either convert logarithm into an exponential, or I can actually use the property of logarithmic equality. All right, so this problem involving with couple property. So since both my terms with the log is on the left side, the subtraction sign here tells me that to go back to a single logarithm, that subtraction sign will become division. So this is going to be log with the base 4 of x plus 2 over x minus 4 is equal to 2. All right. Now I'm going to convert my logarithm into an exponential and solve it from the exponential perspective. So that gave me x plus 2 over x plus 4 is equal to 4 squared, which is 16. Now I'm going to just use, now I'm just using cross product to solve it. All right, 16 times x is 16x plus 16 times 4, 64 is equal to x plus 2 times 1 is still x plus 2. All right. Let's move these around. I think, oh, I wrote it down wrong. It's x minus 4. I'm about to say why all of a sudden there's no solution again. There's a subtraction sign right here. All right, I'm going to move my negative 64 to the right. X come over, so that becomes 15x equal to 66. Divide both sides by 15. So 66 over 15. The exact answer will be 22 over 5. Or you can say it's exactly 4.4. All right, got to have a fraction answer, okay? All right, so this one down here is the same as the previous one. I'm just going to move this term with the log to the other side, so both terms with a logarithm can actually can be on the same side, so I can put them back into a single logarithm. All right, so that's 2 times log with the base 3 of x plus 4 minus log with the base 3 of 9 equal to 2. All right, so let's go back to single logarithm. Subtraction sign here becomes division. All right, this 2 times is supposed to go back up to the exponent. So I get log with the base 3 of x plus 4 whole thing squared over 9 is equal to 2. Now let's convert into an exponential by moving the 3 over. So that's x plus 4 whole thing squared over 9 is equal to 3 come over, become 3 squared, which is 9. All right, cross product, 9 means 9 over 1. So 1 times those two terms are still x plus 4 whole thing squared equal to 9 times 9 is 81. All right, I'm not going to multiply this out because right now what I got myself here is a quadratic equation with two terms. So if it's a quadratic equation with two terms, and my square term is already isolated, all I'm going to do is take a square root on both sides. So I get x plus 4 is equal to positive and negative 9. All right. So x is equal to negative 4, positive 4 come over, become negative 4 plus 9 or minus 9. Negative 4 plus 9 is going to be positive 5. Negative 4 minus 9 is even more negative. So if I plug in negative 13, where the x is at, negative 13 plus 4 will make me take a logarithm of a negative number. So my only answer here is going to be x equal to 5. All right. So these two problems are very similar. Okay. Both of them are 3 terms, but there's one term that doesn't have a logarithm. Okay. Just like this one. Again, this is 4 terms with the one term don't have a logarithm. So that kind of tells me that I will have to convert them into exponential after I make these 3 terms with the log. But after I actually make these 3 terms with the log back into a single logarithm. So this is a plus sign, so these first two will multiply, then divided by x. So this is going to be log with the base 2 of x minus 6 times x minus 4. All right, subtraction sign here means divided by x is equal to 2. All right, move this over here. 2 squared will make a 4. All right, 4 means 4 over 1. We can do a cross product. So this one, I got to multiply it out. So this is actually a quadratic equation. So I'm going to write it out first. X minus 6 times x minus 4 is equal to 4x. All right, for your method, that will tell me that's x squared minus 10x plus 24 equal to 4x. All right, move the 4x over, so that will become x squared minus 14x plus 24. All right, let's see if I can factor this. What times what is 24? 2 and 12? 2 and 12? All right, because that gave me negative 12, negative 2, and negative 14. Since the last sign is positive, both of these got to be negative to end up with a negative 14. So my x is equal to 2. My x is equal to 12. All right, watch. If I put 2 right here where the x is, 2 minus 4 is negative 4. 2 minus 6 is negative 4. So that means I will take a logarithm of a negative. So I actually cannot use 2 for answer. So my answer, x equal to 12. All right. Now, this term is different from the previous 3 because every one of these terms has a natural log on it. So I can actually use the property of a logarithmic equality to help me solve. Because this one, subtraction sign between these two terms on the left will tell me this is going to be a natural log of x minus 2 over x plus 3 is equal to natural log of x minus 1 over x plus 3, that plus 7. So once the natural log are equal, okay, then I can set what they are of equal to each other. So that means I get x minus 2. I purposely put them in the parenthesis because I'm about to do a cross product here. All right, so if I do a cross product, that will give me x minus 2 times x plus 7 is equal to x plus 3 times x minus 1. So for your method will tell me that's x squared plus 5x minus 14 equal to x squared plus 2x minus 1. So, by the way, this is not quadratic because I got x squared on the right, x squared on the left. So they're exactly the same term, so I can actually cancel them out. So the equation I'm actually going to solve is actually linear. So that gave me 5x minus 14 is equal to 2x minus 1. So with the 2x over, that's give me 3x equal to 13, I believe. So x equal to 13 over 3. All right, and 13 over 3 is okay. Okay, so just quickly kind of mention different techniques on how to, that we learned before and how we use those techniques or properties to help us solving our logarithmic equations. All right, that will conclude this video. Thank you for watching.